Welcome to Excel Basics number 7. And in this video, I'm going to recap everything we've done in the class so far and talk about Excel worksheet formulas and what you must know to build efficient formula solutions. Now, the vast majority of people in the world do not know what they need to know to build efficient solutions. So I'm going to recap everything that we've done in the class so far. So when you leave this class, you can be awesome with building Excel formula solutions. All right, let's go over to topics. The topics will cover what you must know to create efficient worksheet formula solutions. 17 topics in this workbook. And don't forget the downloadable PDF notes. 25 topics. There's a few more because there are multiple examples. And these notes are a summary of everything in the video and most of what we've done in the class. So be sure to check them out and learn and become awesome. Now, these 17 topics, some of them are quite easy and simple. But it is knowing all of these every time you approach creating an Excel worksheet formula solution that matter. Everything from starting a worksheet formula, what formulas do, remembering keyboards are fast and an important part of building Excel formula solutions. Default alignment, number formatting, how number formatting affects formulas, Excel's golden rule, all the possible formula elements that can go into a formula, different type of cell references, operators in order of operation, types of formula, rounding, and all of its implications, date and time number formatting, modes of cell editing, logical tests and formula, lookup functions, and of course the dreaded errors. Now let's start it off by going to the sheet first. Now here's ground zero for formulas. All formulas have an equal sign as the first character in the cell. What do worksheet formulas do? They perform math, logical, or data manipulation operations to create an answer. They are the only feature in Excel that updates instantly when source data changes. And for some projects and models, that is mandatory. And of course, keyboards are fast. How do we create our solution quickly? Well, we remember the important keyboards. We never want to take our mouse and go up to Home and then go over to Sum. We want to use Alt equals. And of course, we've been doing that throughout the whole class. When we have to toggle through the different cell references, we use F4 rather than typing the dollar signs in. And of course, we would never click and drag down on a huge column. We use Control-Shift down arrow. Now we have all sorts of other important keyboards that we've learned throughout the class. And those are important for you when you build worksheet models. Let's go over to the worksheet default alignment. Default alignment seems like such a simple thing, but it tells us what data type we have, and it helps us to track down errors. Numbers are aligned to the right, text to the left, and logicals always capitalized and centered. Now, if we look here, can you name all the data types? Well, these are all aligned to the left, so we have text. To the right, numbers. That's a logical. That's a text value right there. The formula is delivering a false, but that's looking at the formula and delivering it as text. Text, all text, and that's a number. Now again, most people in the world, when they sum text numbers, they have no idea what's going on, even though the simple visual cue is there telling you that it's text. That's using default alignment to track down an error. Another beautiful thing about knowing default alignment is if I type the date 1/32/2024 and enter, immediately left alignment says I made a typing error. All I have to do is fix it. 4369. Oh, that's to the left. That's not a number. It tells me to go and fix it. And sure enough, now it's fixed. This happens to me all the time because I'm a bad typer. Oh, I know it's not true because EU is really UE. So just memorize this simple thing, and then tracking down errors is simple. Let's go over to number format. Now number formatting. Everyone in this class knows it's a facade. It just makes the number display a certain way without changing the underlying number. But most people that use Excel have no idea that's true. So what do? Equals 2 times 44. It better be 88. And when it's not, they scream and yell at the formula. It's the formula's fault. But if we look up here, sure enough, someone decreased the decimals. And each one of these has the same underlying number, 43.9. Here, I actually can see the whole number. Here, I don't see a 0 there, but number formatting is showing that 0. So once we select the cell and increase decimals, whether it's just to 9 or showing the 0 that's not really there, now we can see what the problem is. Now down here, that button right there probably is the biggest cause of number formatting error, because when you click it, it shows no decimals. So here we can guess what's going on. If I multiply 1,000 times 6%, well, I better get $6. I don't. I get 55. The formula's making the error. Nope, someone had the correct percentages, or a decimal, 0.055, and then they use this button right here. Now I'm going to apply general because we know that's our eraser when we get into trouble. Click general, and there's the 0.055. Click here. Not what you want to leave your worksheet looking like. Increase the decimals at least to there or to there, and bam, we can see what's going on. Now let's go over to the sheet Excel's golden rule. Excel's golden rule, it says, if a formula input can change, put it in a cell, label it, and refer to it in the formula with the cell reference. Now this goes all the way back to the two guys who invented the spreadsheet, Bricklin and Frankston. They wanted to be able to put formula inputs in cells, label them so it's easy to understand, and then from the formula use cell references to point to each one of the inputs. Then once the formula is done, you just change an input, and bam, the formula updates. Now, violating this rule is the #1 cause of error throughout spreadsheet history. Back in 2000 and about 2010, there were two famous studies done about what causes spreadsheet error. And it was always hard coding numbers into formulas. Now here's examples of formula inputs that change: tax rates, a product name, sales. Here's an example of formula inputs that will never change. So you can just type them into the formula, hard code them into the formula. Hours in a day, months in a year, and original principal or starting amount in finance formulas. Now, here's an example. Calculate the tax to be paid if the sales amount is 100 and the tax rate is 5%. You do not want to type 100 or 5% or 0.05 into the formula. Put them in the cells and label them. Now, I put the labels and added some format, and I put the two different formula inputs into the cells. I added number formatting here, a percent with 2 decimals. And the formula is simple, equals up arrow twice, that's the 100, times up arrow 5%, and I better get $5. And I do. Now I also put a formula off to the side, F2 from video number 5, if any in formula text, to show the formula when we enter it, otherwise show nothing. Now here's our second example. If the sales for your company this year are 230K, and this is 15% higher than last year's sales, what were last year's sales? Now we'll use this formula right here. Following Excel's golden rule, I listed all the variables, the formula inputs, and I put green where we're going to do our formulas. Now let's see if I can explain how this formula works to you with a simple example. Let's say last year's sales are 100 and we're going to increase by 10%. Well, to get to this year's sales, or the end amount, I take begin plus begin times 10%, which would be 100 plus 10 is 110. Well, guess what? We can rewrite this. If we factor out both of these, 100 is left on the outside times 1 plus the percentage increase. And this works because what's 100 times 1? 100. 100 times 10%? Well, 100 times 10%. Now that we have this formula, if our goal is to get to the begin, that's last year's sales, and we only have the end, or this year's sales, and the known percentage increase, well, we can divide both sides of the equation by this. That cancels out here. It's left here. And bam, there we have it. The end amount, or this year's sales, divided by 1 plus 10% gives us begin, or last year's sales. And that 1 right there, we're allowed to type it into a formula because it's never going to change. It always represents whatever the original principal was, the begin amount or the start amount, no matter what it is. Now let's try our formulas. Let's try to get last year's sales from this year's sales. Well, equals up arrow to get this year divided by, and in parentheses, 1 plus percentage increase, close parentheses. And by the way, this formula works whether that is a up or down, positive or negative. And when I hit enter, 200K. Now, if that does work, if we do our formula, begin amount times, in parentheses, 1 plus percentage increase, close parentheses, we better get 230,000, and we do. All right, Excel's golden rule, use it always. Now let's go over to the next sheet, formula element. Now here we have a complete laundry list of every single possible thing you can put into formulas. And we've seen almost all of them. Equal sign, cell references, ranges of cells, spilled range operator, implicit intersection operator. If I scroll down, worksheet functions, math operators, comparative operators, join operator, text and quotations. So you can look through that. Also, cell references. This is a description of the different types of cell references. Both of these are over in the PDF notes. But now let's go look at some examples of cell references on CR1. Now here's the funny thing about cell references. Since Microsoft 365 dynamic spilled array formulas, a lot of times we don't have to worry about what type of cell reference, because that tax rate right there does not have to be locked. However, there are still examples where we need to use absolute cell references and mixed cell references. In this example, we want to see a formula that will require relative and absolute cell references. And the goal in each cell is to just list from the product column all the products that each sales rep sold last week. Well, the first part to this formula, because this is going to have a few parts, is I need to look up Abby, find multiple matches, and then return those items from this column. Now that's a lookup situation, and as we learned last video, the perfect lookup function for that, filter. I'm trying to look up product names, comma, include, this is where we create a Boolean array logical test. Hey, how many of you in this column, which is the same dimension as the product column, how many of you are equal to Abby? Now, we're going to have to keep L6, which is not really L6, that's a relative cell reference, 1 to the left, as relative. But right here, if I double click, I'm going to hit the F4 key. I have to lock that, and double click the column. F4, we have to lock that. Close parentheses. Now, before we copy it, this is going to spill, right? But the goal is to get all of those products into a single cell separated by commas. Now, I only want one of each, so F2. We'll go back to video number 1, where we learned about the unique and sort functions. I'm going to do unique. That'll give me a unique list. And then after I put unique, open parentheses, I'm going to sort. open parentheses. And now I come to the end, close, close. It's still going to spill. We have 2. Let's copy it down just for a second and see if we get. Chantel has 4. So that is working. Control Z. Now we need to just join them together with a comma. And since it's text, the perfect function for that, which we haven't seen yet, is TEXTJOIN. It wants the delimiter, that means what separates each bit of data, in double quotes, comma, space, end double quotes, comma, ignore empty cells. We want to, so we put true or 1 or leave it omitted. I'm going to just skip it and leave it omitted because that's a default. And sure enough, there's the text. Close parentheses, and that formula right there, Control Enter, double click and send it down. Go to the last cell and hit F2. That is working. And sure enough, we used absolute and relative cell references. Escape. Let's go to our next example, CR2. Now the goal is to conditionally format with yellow whatever product name we select from this cell. So when I select Aspen, the Aspen records are highlighted in yellow. Now we're going to use conditional formatting, and this requires a logical formula that uses mixed cell references. Now, a lot of the situations where we used mixed cell references in the past have been replaced with dynamics build array formulas, but not this one. Anytime you conditionally format a row or a column, you got to use mixed cell references. Now, in this class, we have not seen mixed cell references yet. So I want to remind you what a relative and absolute cell reference is, and then I'll show you what a mixed cell reference is and how useful it is for conditional formatting. Here's a relative cell reference. It's 1, 2, 3, 4, 5 cells to my left. So if I copy this over and then down, any particular cell, if I F2, 1, 2, 3, 4, 5 cells to my left. That relative cell reference moves in accordance to where we move the formula. On the other hand, if I select a cell and hit F4, notice it puts dollar signs in. There's a dollar in front of the B reference. This is pointing to B. So wherever we copy it across the columns, it's not going to move away from B. And there's a dollar sign in front of the 13, the row reference. There's 13. So if we copy it down or up, it's locked on 13. Control Enter, copy it over and down. Doesn't matter where we copy it, it's always looking locked at B13. Control Z, Z, Z. All right, now let's try mixed cell references. Now, I would like to show Aspen in every single cell here. But when I copy the formula down, I want to point to sunset and show sunset in every single row. The way we can do this is equals, and if I just point to C13, that's relative. If I hit F4, that's locked in all directions. But what do we want to do? If I copy it side to side, it's the column reference that moves. If I copy it up and down, it's that row reference. And I want the column reference going this way or the other way. I want it to always point to the C column where Aspen is. But when I copy it down, I want the 13 to move to 14 and get sunset. So I hit the F4 key a second time. That locks the row but not the column. A third time, that locks the column but not the row. That's what we want. If I hit it again, relative, again, absolute, it's a toggle. So row, column, that's what we want. If I Control Enter and copy it to the side and copy it down a few rows, wow, that is like magic. Aspen, sunset, and sunshine in every row. If I select this cell and hit F2, that C didn't move. Right here, F2, the C didn't move. The 13 is still there because it hasn't moved up and down. But what happens when we go down? The C is still there, but 13 moved to 14. And why? Because there's no dollar sign in front of it. Over here, F2, C14. If I go down, can you guess what this is going to be? That's right, C15. Now, this is the base of the logical formula that we're going to use in the conditional formatting dialog box. If I come up here and hit F2, what do I need to do to change this so that every single one of these formulas so far is checking against sunshine? Well, equals C5, F4 in all directions. Now I can Control Enter, copy it to the side, copy it all the way down, and bam, just like that. You got to be kidding me. I have the pattern of trues needed to make sure that sunshine is in the row and that it gets conditional formatting. Now, the next thing is F2. We're actually going to have to copy this formula and paste it up into the dialog box. Now, you can definitely just open the dialog box and type it there. But when you're learning, it's much easier to do it in the worksheet, see the patterns of trues and falses, and then copy the formula and paste it up there. But which one of these formulas do we copy? Well, if I highlight from the top left cell down, that means this would be the active cell. That means from this range right here, you want the upper left formula. So I'm going to copy it, highlight the range where every single cell behind the scenes from that conditional formatting dialog box is going to get a logical formula that delivers a true or false. True, you get the formatting. False, you don't get the formatting. There's the active cell, home, over to styles, conditional formatting dropdown. There's lots of great built-in conditional formatting, but not for the row. New rule, down to use a formula, down to format values where this formula is true, Control V. That formula, because I copied that one and I highlighted this active cell behind the scenes, it won't actually be in the cell, but it will be behind the scenes in every cell, delivering a true and false. Now we come over and you can format it however you want. There's all sorts of amazing options. I'm just going to select yellow. You can do border, font, even number. Click OK. Click OK. That is a thing of beauty. Now I have the power to select a product here and change the formatting for the entire row. All right, so we saw mixed cell references here. Over on CR1, we saw relative and absolute. Now, our next task is to talk about order of operations. Now, on this sheet, here's a complete list of the order of operations that Excel uses every time it calculates or evaluates a formula. What? Shouldn't it just be PEMDAS, parentheses, exponents, multiplication and division left to right, and then adding and subtracting left to right? Well, those aren't the only operators, because we have things like ampersand, comparative operators, and reference operators. Actually, that colon is between the two cell references, A1 to A4. And it's got to evaluate to get the content of the 4 cells. So there's all sorts of reference operators. We can have a comma between 2 ranges inside the sum. Of course, we have the spilled range operator and others. So the full order is parentheses, all of the reference operators, negation. And what that means is if you have -2 caret for exponent 4, well, that negation or subtraction or give me the opposite gets calculated before exponents. And then percent gets converted to 0.01. Well, we're never going to type a percentage into a formula. If something is never going to change, type it in as a decimal so it doesn't have to waste a step of converting. Then we have exponents, multiplication and division left to right, adding, subtracting left to right. And finally, at the bottom, ampersand and comparative operators. So I want to look at 3 examples where we have to consider this order with everything above and beyond just our math operators. Now, we've already been taking this into consideration. because we've done time calculations. How do we do it? Equals, and I have to open parentheses, time out minus time in, close parentheses, and then multiply by a number I'm allowed to type in, 24. And why? Because according to this order of operations, I have to use parentheses to force subtraction before multiplication. And sure enough, number formatting got pulled over here. So Control-Shift tilde or grave accent, that's our keyboard to apply general. Here's another example. I want to compare 50 to whatever the sales are, but we haven't calculated the sales yet. Now this never changes, so we're going to type it right in. And I have to ask the question, are you less than the sales, which of course is price times units. Another way to look at this is, hey, are the sales greater than the hurdle? And I get a true. And why? F2. Because left to right, it has to skip over that comparative operator because that's at the very bottom. It does multiplying first, then it comes back and does the less than. Now to see this in action, I have the cell selected. I go up to the Formulas tab, Formula Auditing, and click Evaluate Formula. Here's our formula, and the underline means it's about to calculate that. So it's got to see what's in E10, evaluate. Got to see what's in F10, and now it multiplies. And guess what? That comparative operator is evaluated last. And sure enough, we get true. Now here's one we already did in video 2. We have customers, and we have sales from last year and credit rating, and these are hurdles. We need to count how many customers pass these two logical tests. Now this is an OR logical test, so what do we have to do? I'm actually going to do it off the side, and then I'll put it over here. Well, we have two things we need to test. We need to ask, hey, how many of you are greater than 250? And then as a second logical test, I have to ask how many of these are greater than 4. Equals, in parentheses, how many of the customer sales from last year are greater than 250. If I close parentheses, so far, I do not need these parentheses. And actually, you see a lot of formulas in the working world where people put unnecessary parentheses. If this was the calculation, it would be unnecessary. But we have a few more steps. That's the first OR logical test, F2. And because it's OR, we know the math operator for OR is plus. And then we ask the second question. Are you greater than the credit rating hurdle? Close parentheses. So why do we have to use these parentheses? Well, because these comparative operators are at the bottom. And we definitely have to calculate all the trues and falses first and then add. So that's another example. And we get our 2 because this person passed both. But in an OR logical test, all you need is 1 or more. This person got 2. The second customer, PCC, they passed this one, but not this one. So they only passed 1. As we learned earlier also, in Excel, any non-zero number is interpreted as true if, there's the logical test. It's a bunch of 2s, 1s, and 0s. Everything that's not a 0 is considered true. Comma, value if true, I'm counting, so I put a 1. Comma, I don't have to put a 0 there. I don't have to put anything, because if I don't put something into the if, it puts a false in. And the next step, when we Control-Enter, those falses, now I just need to sum to get a count of 3 customers past this OR logical test, F2. And sum is programmed to ignore logical values. So there's our final formula. I'm going to copy it. And I copied it in edit mode because those are all relative. If I copied and pasted, it not only would wreck the formatting, but it would, the references would move. So I copied it in edit mode, Control-V and Enter. So those are 1, 2, 3 examples of where us knowing the order of operations is important in building the formula. All right, let's go look at the next sheet. Well, formula types, it's here and it's over in the PDFs, so you can read it. But let's just go look at some examples. I will go over to F data type. Now, the first formula type we're going to look at is formula by data type. And when you create a formula, we can have different results: number, text, or logical. So we can have number formulas, text formulas, and logical formulas. A simple example of a number formula is we need to calculate sales, price times units. And when we hit enter, we have default alignment that tells us, yes, that's a number. Now, we don't just do number formulas. We can do text formulas. And here's a great example. This is a description from an invoice. And unfortunately, embedded at the end of the description is the code we need to do a lookup to get the product price. Well, we can extract everything after that dash and then use that as the lookup value. There's a great function called text, and there's an after and a before. We want after. Select the cell, comma, and the delimiter in double quotes, dash, end double quotes. Close parentheses. And when we hit enter, if we don't know default alignment, we're happy. Because what? We have our lookup value. I'm going to use XLOOKUP. Lookup value, comma, lookup array, comma, return array, because that's what I'm trying to get, that price. Control enter. What? Why is there no match? Well, for those of us that do know default alignment, that's text, this is number. We're never going to make a match. Well, it's simple. And let me get this up here just so we leave a trail. Copy, enter, equal sign, control V. Any math operation will convert numbers, dates, and times, which are all numbers, back to numbers. I'm going to do +0. It doesn't change the value, but it does provide the math operation control enter that converts it back to a number. Now, I'm going to copy this, control C, enter, F2. Now, I did an accounting conference once, control V, down in Tacoma, Washington at the Poodle Dog Restaurant. And when I showed this trick, a bunch of accountants stood up and said, "Where has that trick been all my life?" So when we control enter, now it's easy. We have number, we can make a match and do our lookup. Hey, the third type of formula, of course, is logical formula. And you can prove to yourself equals, hey, text number, are you equal to number? Control enter, we get a false. A text number is never going to be equal to a number. Now, I always add 0 just so you know, backspace, backspace. I always add zeros on simple lookups like this, usually because I'm at the end of the formula and it's easy to type +0. But if you have a big array of text numbers that you're trying to convert to numbers, it's faster to use the math operator double negative. Negation is a unitary operator. And even though it has to operate twice, it calculates more quickly than any of the other possibilities. In fact, there's been lots of tests done over the decades to prove that that is correct. But double negative, +0, times 1, they all work. Now, over on text numbers, here's something silly that Microsoft did. Well, maybe it's not silly. They have a function for numbers, dates, and times to convert the text equivalent over to an actual number. But I always use +0 or double negative because it's faster than typing these out. Now I'm going to select the cell right below the text number, the cell directly below the date by holding Control, and then Control selecting this. That's the active cell. And notice the text value is above each one of these selected cells. So the formula I want to populate into all those selected cells equals up arrow +0. Control Enter to populate all the selected cells with whatever's sitting in the active cell, Control Enter, and plus 0 is much easier than these functions. All right, that is formulas by data type. Let's go over and look at formulas by calculation type. Now we want to talk about formulas by calculation type. For example, if we use the sum function to create a total, that's called an aggregate calculation. And an aggregate calculation takes many and delivers a single answer. We take many numbers and sum to deliver a single answer. We take many numbers and calculate an average, which is an aggregate formula, to deliver a single answer. That's different than dynamic spilled array formulas or scalar array formulas. They take many items and deliver many answers. A dynamic spilled array formula spills a bunch of values from the top cell. A scalar array formula takes an array calculation but has some aggregation around it like sum. Now, different from both of those are the old school formulas, single input, single output formulas. That's where we, in a single cell, multiply one item times another item. We have an operator and items on either side. We also want to talk about Excel table formulas, and in particular, Excel table column formulas. Now, Excel tables, we haven't seen how to create one, but we're going to create one, and we'll see that the advantage is if you're going to be adding new records to the bottom or taking them away, anything pointing to the table automatically updates, including a column formula, which automatically is added to each new row that you add. Now, we're going to compare and contrast each one of these formulas. But in particular, I want to compare these three because all three formulas are situations where we're creating columns. So we want to create a column of formula, same formula in each one, 1, 2, 3 ways, and see when is the best time to use each one of them. Now, I can already tell you for single input, single output formulas, since they're harder to create than either one of these, the only time we're really ever going to use these is if we get stuck on a computer that doesn't have Microsoft 365 Excel. Or perhaps you have to send the result to someone who doesn't have Microsoft 365. Now, for all three formulas, we're going to multiply the sales amount in each row times the tax rate. And of course, as we learned earlier, since the tax rate has decimals past the penny position and the formula results are going to be used in a subsequent formula, we have to use the round function. Equals round, left arrow, times up arrow. And we have to lock because we're going to manually copy this. F4, comma, we want to round to the penny, so 2 close parentheses. Control Enter. We have to manually copy this. We have to check the last cell. Cell references are working. Alt equals to get our aggregate sum calculation, and Enter. Now, remember, lock, manually copy, and if we have to edit, we have to come back to the top cell and then recopy. Let's compare that to dynamic spilled arrays. Equals round, left arrow, shift down arrow, times up arrow. I do not have to lock, comma, 2 to the penny, close parentheses. I don't have to manually copy. I just Control Enter. The results spill down. Control down arrow, and then down arrow. Alt equals. We can see the spilled range operator. That is a beautiful thing because since the formula only lives in the top cell and it can expand or contract, dynamic spilled range operator says I'm always going to get everything that spills from that top cell. Also, let's remind ourselves about the characteristics of dynamic spilled array formulas. F2. The formula only lives in the top cell. If I hit Enter, I see a ghost up in the formula bar. F2, there's nothing there. Well, you can still refer to that value. Enter, so I get the value in other formulas, Control Z. But because the formula only lives in the top cell, they had to gray it out. Also remember, if you type anything in the way of the dynamic spilled array formula, the spill error is polite. It says, hey, you put something in my way and I can't spill. Control Z. So the advantage is F2 to a dynamic spilled array formula. Well, we don't have to lock. We don't have to manually copy. And if we have to edit, it automatically spills the new result. We don't have to recopy. All right, now let's talk about Excel tables and Excel table formulas. We have a proper data set, field names at the top, records and rows. We could, with a single cell selected, go up to Insert, Tables, and click the Table button. But we're going to create a lot of Excel tables in future videos when we do data analysis. So the keyboard Control-T is the way to go. My table has headers. Click OK. Immediately go up to Table Design. Table 1 is not a good name. Naming things properly, whether it's a worksheet or an Excel table, is important so we know what's going on. I'm going to name this. Click up there. Tax Table. No spaces or special characters, and Enter. Now we have an Excel table. Now we're going to create a formula, round. And when I left arrow, we get table formula nomenclature. Because this column is called sales, if we used sales without the implicit intersection operator, which is the @ symbol, it would give me all the values, because square bracket with sales means, hey, give me the whole column. We use that outside the table. But when you're in a row, that @ symbol means, hey, I'm going to get whatever value is in this row where the formula is in the sales column. Times, and then up arrow. And yes, we have to lock when we're in an Excel table, F4, because technically this is a single input, single output formula. The advantage, though, comma to close parentheses, is that the Excel table feature itself copies all column formulas down automatically. So when I hit Enter, the column is populated. In fact, every cell, F2, contains a formula. So the reason we'd use an Excel table, which we'll see in just a second by adding new records, is, yes, we're going to add records later. And although we have to lock, the table feature does automatically copy the formula down. Now, a great thing about an Excel table is we can add a total row. In fact, let's select the cell at the bottom of tax amount. And this is before we add new records. We add this total row, and if we add in new records, the total row gets pushed down. I'm going to use the keyboard Alt equals. Now, it adds a total row. It's part of the table. If you click the drop-down, you actually can choose different functions. We have sum. If you look up into the formula bar, it's not the sum function. It's subtotal. 109 means sum. If I change the aggregate calculation to min, I can see it has a different number. You don't have to worry about those numbers because it's all automatic. Now let's see if we can add a record. Now, I would never have stuff below the table if I was going to add a record. I click in the last cell on the right, right before the total row. And if I hit Tab, it adds a record. That formula just copied down. If I type 5, Tab, I can see the formula was automatically copied down. Now I'm going to Control Z, because let's look at an Excel table formula outside the table. I just want to add these values outside the table. Alt equals. And instead of using my mouse to highlight, if you have an Excel table, you go to the field or column and point right at the top. And when you see the downward pointing black arrow, you click. It puts in the table formula nomenclature. That's the name of the table, and in square brackets, the column or field name. Enter. Now, this is 204. So is this. Now let's add a new record with Tab. 5, Tab. That updates. This updates. And the Excel table was polite and copied the formula down. So we use Excel table column formulas when we expect to add or take away records later. Now, the last formula we want to talk about is the scalar array formula. Scalar just means a single value. Now, let's come over here and F2. We created this dynamic spilled array formulas because we wanted to see all the individual values, and then we wanted a sum total at the bottom. But what if I didn't need all these individual values? I just wanted to jump to the total. I had this column here, but I didn't want this column. Control-C, Enter. I come over here, equals sum, tab, Control-V, close parentheses. Now, if I highlight everything inside of sum, I can see this is an array formula. It is acting on an array of items and delivering an array of answers. That's why it's an array formula. As soon as we put an array formula into an aggregate formula, because an aggregate calculation delivers only a single value, that's why it's called scalar array formula. If I hit Enter, I get the full answer. If I were to, just for a second, remove all this, I still have the total over here. Control-Z. Also, because each one of these amounts is going to be used as a separate amount, they have to be rounded individually. That's what we did here. We did the multiplication and rounding first. If you reversed, summed it, multiplied it, then rounded it, you get the wrong answer. So we have single input-output formulas if we're on a computer not with Microsoft 365. We use dynamic spilled array formulas because they're much easier than old school formulas, and we don't need to add records later. We use an Excel table column formula when we're going to add records later. If we're outside a table and we're pointing to an Excel table column, well, we automatically use table formula nomenclatures. Actually, up in Options, you can change that so you don't use table formula nomenclature. And you use a scalar array formula when you want some aggregate total, but you don't want all the intermediate calculation. All right, let's now jump over to CR3. Now, this is actually cell reference 3 following up our conversation about cell references. But we just talked about dynamic spilled array formulas, and I got to show you one of the most amazing dynamic spilled array formulas that replaces a much more complicated older formula. Now, this is a typical budget where we've estimated the sales for 6 months. And from the accounting department, we have expenses as a percent of sales. So for example, any intersecting cell here, for example, we need to calculate the supplies expense for February. We would multiply February times the percent or decimal, Control-Enter, and that would be the expense for this month. Control-Z. Now, let me show you the more complicated formula before I show you the amazing dynamic spilled array formula. Now, what makes this formula complicated is we have to use mixed cell references. And for most people, they are quite hard. But there's a second part that dynamic spilled array formulas will blow away. We used to have to enter this, Control-Enter, copy it down, one step, let go, re-grab it, copy it over. Second step in copying, go to the last cell, F2, to check if our mixed cell references are working. Control-Z, Z, Z. Now let me show you the revolutionary dynamic spilled array formulas. Round, well, we just take all of the column headers for this rectangle. Those represent all of the sales over 6 months, times, and then the row headers for this rectangle here, those are all the expenses as a percent of sales, comma, 2 close parentheses, no mixed cell references. And when I Control-Enter, no two-step copying. You got to be kidding me. Then, if we want to quickly add, watch this trick. I'm going to highlight everything. And when you do that with empty cells all around, you can use Alt equals, and it puts the sum function in each cell. This properly gets the row, and you can check. And this properly gets the column, each one of them. And this one just adds all of these, which is the same as adding all of these. Then we finish this amazing budget off because we got to figure out the net income or profit equals all of the revenues minus the dimension that's exactly the same that contains all the expenses. Control Enter. And I didn't quite go far enough. F2, I'm going to change this since this is J. I'm going to change this to J. And this one to J. Now we have the same range, but including the totals because we want the overall net income for the 6-month period. Control Enter, and bam! Dynamic spilled array formulas have just revolutionized budgeting. Now, one important thing about this setup, this rectangular setup, is sometimes we don't get our formula inputs in the right vertical orientation. A lot of times assumption tables come like this. In the old days, mixed cell references just 100% could not deal with that. You had to have vertical and horizontal, or you had to create multiple formulas. However, with Microsoft 365 Excel, there's a great function called toCall. The array, I'm just going to highlight. All the percentages are decimals. Control Enter, and now I have it in the right orientation. F2. At the beginning, round, we have the expenses as a percent of sales times, and of course multiplication can be done in any order, comma 2 close parentheses, and bam! Without the number formatting, we get exactly the same answers. Now here's another cool thing about dynamic spilled array formulas. That's a whole rectangle. If I want to move it, all I have to do is move the cell with the formula. So I'm going to use my move cursor and click and drag to the side. Because if you really wanted to spill a sum, as we saw in video number 1, Microsoft has a brand new function called equals by row. We put an array, comma, and because we can never get a sum function by itself to spill because it's aggregate, it always delivers a single answer, we use the function sum in by row, and it automatically says, hey, I'm going to take sum, and across this array, run it row by row. Close parentheses, Control Enter. Similarly, equals by call. There's the array, comma, SUM, close parentheses, and bam, I've spilled the results. All right, next we want to go talk about round. But before we go to this sheet round, I want to go back to F calculation type and remind you about the round function. And this is in the notes. We have covered this throughout the class. This is something you cannot forget. Because if you forget, when you have to round, then things like invoices, payroll can be incorrect. Now, when do you round? Well, the first thing is, do you have to round? Well, with money, there's only up to pennies, so you have to round to the penny. Do you have extraneous decimals? Meaning for us, the penny position, do we have any decimals past that? Well, we do right here. When we multiply these, we're going to get lots of extra messy decimals past the penny position. Now, 1, 2, those two things alone do not qualify for requiring the round. Because if you're never going to use any of these in a subsequent formula, you can just show the results using number formatting. But number 3 is if you have a bunch of messy decimals and you're required to round, and you're going to use it in a subsequent formula, bam, those 3 things mean you're required to round. Now let's go over to the sheet round. Now, here's what I want you to remember about round. We usually round either to the penny or to the dollar in business. Now, here's your memorization trick. You start at the decimal and count to the right 1, 2, 3, 4, always positive. So 1, 2, that is the penny. And properly, that gives us a 9. This one gives us an 8. When we're rounding to the dollar, if we're counting to the right, 1, 2, 3, this direction is backwards. 3, 2, 1, 0, minus 1, minus 2, and so on. So to the dollar is 0. Now here's one I did not teach you, but I want to show you now. What happens if we're going to round a percentage and someone communicates to you, hey, I need you to round to the 10th of a percent. Well, I'm looking, and the 2 is in the 10th position. But do formulas see number formatting? No way. Is percentage applied as a number formatting? Absolutely. So what do you have to think of? The underlying number. This is the underlying number. So if the 2 up here is the 10th of a percent, to translate how it was communicated into what you need to put into the second argument of round, well, you look at the unformatted number, and that 2 is third position. So I type 3, close parentheses, and enter. Now, the round function is not the only function that does rounding. We have a great function called MROUND. And instead of rounding to a position, it can round to a certain amount. And this is common in pricing. Now, we have two amounts, and we want to round to the nearest $5. If we take 5 and divide by 2, that's 250. So anything 250 and up goes up. 249 goes down. So let's try this. Equals MROUND. And I'm going to do one price at a time because MROUND is one of those functions that cannot handle an array operation. That means more than one item. Now, there is a trick with double negative, but we're not going to do it. Comma, and I want to round that amount to the nearest $5. F4, close parentheses, Control, Enter, and copy it down. And sure enough, this went up to 45. This went down. Another use for MROUND is in payroll. We have times, and we want to round to the nearest 15 minutes. Equals MROUND. We're going to take 8:06. And I have the time, an actual time value, in the cell already, which we're going to reference. But I can tell you right off the bat, 7.5 is half of 15. So this is going to go down. This one should go up. Comma. There's the multiple, a time value that represents 15 minutes, F4. Close parentheses, Control, Enter. That went to 8 a.m. This one went to 8:15. Now, another option where employers are more kind than this, they might say, hey, we want to always round up. Well, in that case, you can use another rounding function called CEILING.MATH. Ceiling means up, and floor means down. We're rounding to an amount, either up or down. Here's our 15 minutes equals ceiling. And this function definitely can handle array operations. Comma, and there's to the 15 minutes. Close parentheses. These both should go up. So when I hit Enter, sure enough, they do. Another function is floor. If we're rounding always down to the nearest $5, then of course anything $4.99 all the way down to a penny is going to go down. And floor does just that. All right, now let's go over and remind ourselves about date and time formatting and formulas. All right, when it comes to dates and times, here's what I want you to remember forever. A date serial number, that means under the number formatting, equals the number of days since December 31st, 1899. So 1/1/1900 equals 1, and 12/30/2024 equals 45,656. When you know this, you know why the formulas work. When you subtract one date from another, it gives you number of days. For time, a time serial number equals the proportion of a 24-hour day. So when you enter 8 space AM, behind the scenes, Excel says 8 divided by 24, is 0.333333333, 1/3 of a day. Now, if you want hours when you are dealing with time, since up front, Excel divided by 24, when you take later time minus earlier time in parentheses, you got to multiply by 24 to bump it back up because it was divided to start with. All right, if I highlight these in Control-Shift-tilde, which is the keyboard for the general number formatting, sure enough, when I'm about to subtract that date from this one, it's just numbers. Control-Z, so equals later date minus earlier date. And you got to be kidding. This deadbeat has been past due on this invoice for 26 days. Now, sometimes you need to not just know number of days, but, for example, number of work days. There's a bunch of great functions that deal with dates. For work days, we use the function .NET work days unless the weekend is Saturday and Sunday. This is the one to use because here's the start date, comma, end date. And this amazing argument here does oh so many things. If our weekend is Friday and Saturday, we select 7, comma. Not only that, holidays, we just highlight them. When I hit Enter, 38 work days. Now, if I highlight these times, Control-Shift-tilde, sure enough, when I entered the times thinking they were hour integers, no way. Excel divided by 24. Control-Z. We want to calculate the time value, then the hours, and then using the wage per hour, calculate gross pay. Equals later time minus earlier time. And when I tab, in this case, the formula sucking the number formatting is perfect. I'm going to, in a separate cell, just say, hey, that times 24. Control-Enter, because I don't know why that didn't suck the number formatting. I was about to Control-Shift-tilde. Maybe Excel finally changed something. Tab. Now, we never round the actual hours worked, but I'm going to assume we use this somewhere else. When you multiply hourly wage times the unrounded hours worked, we do, in this case, want to use round. So hours worked times hourly wage, comma, 2 close parentheses, and 140.05. Now, in this case, we're going to round time, both of these, up to the nearest 15 minutes. Since it's up, we look up, and there's the ceiling. That means that's the function we're going to use. So equals ceiling, arrow, later time minus earlier time, comma. And guess what? 15 minutes. I always use 15 minutes in this particular situation. So I'm going to hard code it in. You can actually hard code a time value, 0, 0, colon, 15, in double quotes. And it gets it. It knows the underlying decimal that it should use to round up to. When I tab, sure enough, up here I got 505. But the ceiling, rounding up to 15 minutes, is 515. Equals that times 24 tab. That, I've never seen that before. It didn't suck the formatting. Wow. OK, I like that. And actually, I have the same layout here, so I can just copy this formula, Control-C, Control-V. And we round it up to the nearest 15 minutes. And there's a little bit more gross pay. All right, so you know what to remember forever when you're using Excel. All right, let's go over and see something kind of cool, modes of cell editing. Now, the rule for when to use your arrow keys or your mouse to go get cell references for a formula is if the inputs are close, use your arrow key. If they're far away, then use your mouse. Now, I got to show you something that happens when we use our arrow keys. And it has to do with the status bar right here. Notice it says ready. That shows up when you have a cell selected. And you can enter whatever you want. But watch what happens down here when I type an equal sign. Enter means when you're done, you can hit Enter, or you can use your arrow keys. Left arrow, up arrow, down arrow. Now notice when I use my arrow keys, the third possibility down here is point. That means I'm pointing towards some cell reference. But if I want to do something like multiply, and notice it says enter because it's ready if I'm done with the formula to hit enter. But watch what happens if I accidentally click with my mouse. It says edit. Now the arrow keys do not work. I'm using right arrow, left arrow. Well, that is by intent because sometimes you want to arrow through to delete something. But if you're trying to enter cell references, it's really annoying. So I'm going to back arrow to get to the end. And it still says edit, but watch what happens when I hit the F2 key. Now, I haven't hit it yet. The F2 key is how you get back to enter, so the arrow keys work. I'm going to hit F2, and now it says enter. And I can use my arrow keys. Point or enter allows you to hit enter, and then there's the formula. All right, now let's go look and review a lot about logical tests. Now, here is most of what we learned so far in the class about logical tests. And here's the thing about logical tests. They are everywhere. A lot of the formulas we create involve logical tests. Starting next video, we do data analysis. Almost all of that is logical tests. Now, here are the different logical tests we learned about in the class. And here are the formula elements we used when we created logical formulas. Here are some functions and, of course, comparative operators. Now, let's start off with a single condition logical test. And our goal is to average the sales. Our condition will be quad. So we have to find all the quads here, jump over, find the sales, and then average them. Now, just as we used SUMIFS, COUNTIFS, MINIFS, and MAXIFS, there is an average ifs with an S function. Now, when we used SUMIFS, this said sum range. When we used MINIFS, it said min range. Here, because we're averaging, it says average range. The first argument always, except for COUNTIFS, contain the numbers that we're going to conditionally do some calculation on. So average range, comma, criteria range. Well, it says range, so I'm going to highlight the whole column, same size as the sales that contain all the products, comma. And since we're doing a single condition logical test, criteria range 1 goes with criteria 1, and there's the condition. Close parentheses and enter. $533 and 1/3 dollars. That's the average sale for the quad product. Now, the next logical test is a not logical test. That means not equal. So if we ask the question, hey, which sales reps are not equal to Chantel? Not, that is equal to Chantel. So that gets a false. These get trues. Now, we're using a comparative operator and the condition in the cell. And you can see the alignment. It's to the left. That means it's text. As we studied earlier in the class with COUNTIFs, SUMIFS, AVERAGEIFs, MINIFs, MAXIFs, that's what they expect. They expect comparative operator and condition together as text. Now, here are the different comparative operators. And here are the 3 different ways that we can put comparative operators into logical formulas in Excel. When we're using COUNTIFs and SUMIFS, we can put the condition in the cell just like that, like we have right there. Number 3, if we need to use, for example, the condition Chantel other places, and we can't put the comparative operator in the cell, then we join it. And remember, this has to be text. Whatever the thing in E7 is, we're joining it to the comparative operator in double quotes. We'll see this example in just a moment. The third location where we can use comparative operators, and we've done this a lot in this class, is when we're doing a direct logical test. Like, here's the range, and we want to ask the question, how many are equal to whatever's in D6? Here's another example here. All right, so we put not Chantel into the cell, and we want to count. This is where we use COUNTIFs. It doesn't have a sum or average range because it just needs the actual criteria range. sales rep, comma, and criteria 1, not Chantel. Close parentheses and enter. So 15 of the sales were not made by Chantel. Now when we do an OR logical test, we either do it over one column or two columns. The formula we use for 1 and for 2 are different. But it doesn't matter if we're working an OR logical test over 1 or 2 columns. The OR logical test itself is the same. And it means however many logical tests we have, all we need is one or more true for the OR logical test to deliver a true. All right, we want to ask the question, hey, how many of the sales are for Lung or Sue? They're a team. So we have to look through here and say, is that Lung or is that Sue? When we're only using one column, then we can, because our goal is to add the sales, use SUMIFS and do a function argument array operation. Sum range, hey, there's the sales, comma, criteria range 1, sales rep, comma, and in criteria 1, because it's one column, we can just put both names in. That's doing a function argument array operation because we're putting more than one item. We have 2, so SUMIFS will give us 2 answers. The total for each sales rep. Close parentheses. This will temporarily spill. You can see they're there, Control-Z, F2. But we just put that inside of sum. 4,300 for the team of Lung and Sue. Now, we've already done this one actually just a few moments ago, but we're going to do the OR logical test. Hey, is the sales rep Bree or is the product quad? Because it's 2 columns, we might, like right down here, get a count of yes, that's true, and yes, that's true. If we added those, we would double count. So as we've seen a few times before, we're going to do the 2 Boolean array logical tests separately. And because it's OR, we add. Equals, hey, anyone there equal to Bree. Now notice that's an operator. It's not text like we had up here. So when we use comparative operators, this is one of the ways. A direct logical test like, and we put it in between either an array or single items on both sides, and it delivers trues and falses. Close parentheses plus, hey, products, are any of you equal to quad? Close parentheses. If I highlight this and hover, we get an array of 0, 1s, and 2s. If we just added these, because we're counting, we would double count. But luckily, in Excel, any non-zero number is considered true. 0 is the only number that is considered false. So we put this into if. There's a logical test. And if we get a true, we want a 1. Not a 2 or a 1, just a 1. We can leave this argument out. It'll put falses in. We get 1s and falses. And now all we have to do is add, because the sum function ignores logical values. Control-Enter. There's our formula without double counting. 7 records have the sales rep Bree or the product quad. Now, an AND logical test is different than an OR logical test. For an OR logical test, all you need is 1 or more trues for the OR logical test to deliver a true. For the AND logical test to deliver a true, however many tests you have, they all have to come out true. Now, for this example, we want to count Bree's sales, there's Bree, bigger than 700. There's 700. I would like to put the comparative operator right here, just like we did up here. But guess what? This is a situation where that 700 is being used in another formula. So we can't put it there. No problem. We're going to use this option here for comparative operators. Now, for an AND logical test, COUNTIFS, SUMIFS, MAXIFS, all of those functions do an AND logical test by default. Equals COUNTIFS, criteria range 1. We'll ask, hey, sales rep, comma, criteria 1, are you equal to Bree, comma, criteria range 2, we're going to look at the sales, comma, criteria 2. Now, we want the bigger than side to point over to all the numbers in the column. So that's why if we were to draw it here, it would be like this. So in double quotes, greater than, that is pointing towards the column. And then we join it with our ampersand 700. Notice the little side is pointing towards 700. And exactly 700 doesn't count. That is one logical test, two logical tests. Control Enter, and there are two. Let's see, Bree, Bree, and Bree. And sure enough, 1, 2, because that one's not included. We don't have an equal sign. Now, the functions that can perform logical tests, here are some of them. Is functions. They check if something is true and then delivers true or false. So ISNUMBER, ISNA, and a bunch of other ones. Let's check to see if this is a number. We've been having trouble with that number, so we're going to check. And that's a single item, so enter. False. Well, if we come over and investigate, there's that lead apostrophe. The and or, and not also, those are aggregate functions. You cannot do an array calculation that spills. They only do one and logical test and deliver one true or one false. Let's check and see if both are greater than 0. Equals and. Hey, are you greater than 0? And I'm going to type that in because it is not going to change. And are you greater than 0? Control true. Well, probably number formatting. I click, and sure enough, someone decreased the decimal. Now, we also have if and is functions. In fact, we just did if up here. Control C, enter. This is an or logical test across 2 columns. Here, we're going to do the same logical test, but we want to add sales. So instead of a 1, I just highlight all the sales. If I click inside sum, click on number, and hover, there you see the falses and numbers. So sum will ignore the falses and add the numbers. There's the total. Now, I got to show you a great alternative. We used sum, if, and then put our sales there. But what if I took this logical test, Control C, enter. Instead of using if, I could use filter. I'm just going to take these numbers. That's the array, comma, and include Control V. Those are the trues and falses. Close parentheses. Well, there are the numbers that meet the conditions. So then I just put this inside of sum and enter. Now, we've already done lots with SUMIFS and all those ifs with an S, but let's do equal min ifs. Min range, that's where we put the numbers where we want to find the min, comma, and we're going to ask the question of all the sales reps, comma, what was Bree's minimum sale? Close parentheses, and 700. All right, so that is an epic review of logical tests. As you go through your Excel career, you will do so many logical tests, and this is a great summary. Now, we also want to remind ourselves just of lookup. So we're going to go over to the sheet lookup. Now, looking things up in Excel is one of the most common tasks that we do. And Excel has all sorts of amazing lookup functions. XLOOKUP is the most versatile. It does all sorts of things. One thing it does really well is it can look up a record and look up value. If we look up employee ID, get a match here, and notice there are 4 rows. That's lookup array, comma, return array. As long as it has 4 rows, it can have as many columns as we want. And it will return all the columns when it finds a match. So close parentheses, and we looked up a record. Another really common lookup situation is when we're looking up tax rates, commission rates, discount rates. And These type of lookup tables almost always come as a table with the first column sorted smallest to biggest. And if the thing you want to return is in the last column, don't use XLOOKUP or VLOOKUP. Use the original lookup function equals lookup. We're going to use the second option, and here's how easy it is. There's the lookup value, comma, highlight the table, and that's it. Now, in our lookup video, we talked all about this and how the two advantages are it's faster to create, and it actually calculates much quicker. Close parentheses and enter. We have looked up our tax rate. Now, we just saw the filter function, but the one thing it does that all the other lookup functions cannot do is when they're duplicates, every other lookup function only returns the first, sometimes the last. But filter, we can take one lookup value, find multiple matches, and return multiple items. Equals filter. The array, that's where we're trying to return all matching records, comma, include, that's where we need our logical test. I say, hey, how many of you are equal to? We'll use an equal sign, quad. Close parentheses, and filter comes to the rescue. It does one thing that none of those other lookup functions can do. One lookup value, return multiple items. Now, another great lookup function is xmatch. And what it does is it can look up a name like Lung, and it finds the relative position of the item in the list. So it would report 3. One of the great uses, however, for xmatch is to compare two lists, to ask questions like, is an item in both or just in one? Now, equals xmatch. For lookup value, we're going to give it everything in list 2, comma, lookup array, everything in list 1. Close parentheses and enter. So anytime we see a number, that means the item is in both. So what do? Is number. Close parentheses and enter. And so we get true, true. Chantel and Lung are in both. Now, if we want the opposite, who's in list 2 but not in list 1, I'm going to paste the same formula. Instead of is number, we're interested in NA. So is NA. So we wrap that around match, and now we find out who's just in list 2. Miki, Gigi, Sue, and Pops. Now, this is common to have a column of trues and falses. But what if we want to extract the names that are just in list 2? Well, guess what? We already have an array of trues and falses that we can use in filter. So I'm going to copy equals filter. I'm looking stuff up here, comma, include Control V, close parentheses, Control Enter. Now, if we want names that are in both, we have the same formula, but instead of is NA, it's is number. And bam, just like that, we've extracted Chantel and Lung because they are in both lists. All right, the last sheet we want to look at is errors. Now, here's a list of the most common errors, and I want to take a look at a few of them. Now, divide by 0, you probably know what that is. That's when you divide by 0. It's not allowed. Reference. That is when you have a cell reference in a formula, and you delete the cell. Reference means the cell reference is gone. Also, if you have a formula pointing at cell A1 and you copy it over, well, it tries to move past A1, and there's no reference there. So you get reference error. Name, that's when you misspell a function or put text without double quotes. Value means you put something incorrect on either side of an operator. You can't multiply text times a number. Or in a function, that's expecting a number, and we put text in. Num, that means you have a number that's too big or too small. This is silly. Large can find the first, second, third largest value. And there's only one value in array, and I said, hey, give me the third. So it says num. The number's too big. Pound symbols, that means the column is not wide enough for a date or you have a negative time. And circular reference. This is the dreaded one. I'm going to try and sum. And I accidentally select the cell with the formula. When I hit Enter, circular reference. The problem is the formula is in a cell. It's trying to calculate an answer, but it needs the answer from the cell it's in, so it just goes in circles. Now, if you have circular references, you should delete them. Because if you don't, every time you open the workbook, it gives you a warning. All right, that was an epic video. We talked about errors, lookup functions, logical tests, modes of cell editing. We reminded ourselves about date and time, the round function. We saw a great use for dynamic spilled array formulas when we're building a budget. We talked about the different types of formulas we can encounter. We also talked about the order of operations and how knowing the order of operations helps us build formulas. We talked about cell references, Excel's golden rule, number formatting, and of course, default alignment. And don't forget, at the end of the workbook, there's a bunch of homework or practice problems. All right, this is Excel Basics 7. We'll see you next, Excel Basics number 8, for the first video about data analysis. All right, see you next video.